Welcome to 5TN. I'm your host, Dr. Yavuz Selim Silay. I love sharing the wonderful technology news about the world with my friends in Africa. Our first news is actually about Imagine Tomorrow. There is a very exciting international entrepreneurship and innovation event that is held on 19th to 21st February 2020. As part of URI. URI stands for Eurasian Higher Education Summit, which brings Europe and Asia together. Every year, URI is continuing, and Imagine Tomorrow is a program where we contribute as well. And in this event, this is the second one, where I'm really thrilled and excited to announce, because it is all about technology. There will be many different incubator firms, science parks, technology transfer offices, and individual entrepreneurs. We have very important guests coming to this event, including the Turkish Science and Industry Minister, Mustafa Varank Bey. And this is really an exciting event where more than 300 universities, more than 60 countries are present. And here I want to show you a video about last year's event. And I really welcome all of you to Turkey to attend our events in the future as well. Thank you very much.
Unforgettable, magical city. Welcome to Istanbul.
Our second news is about a very popular situation, an unfortunate situation, coronavirus. There actually has been a very interesting development. There are now computer models simulating the future spread of new coronavirus. By actually using this very unique technique, these researchers are trying to clarify the confusion around the outbreak and really understand the patterns of how to use it. So, of course, this is a very scientific and technological work. Chinese women are actually wearing different protective masks as they walk during a snowfall. And unfortunately, there are many cities that are empty and shuttered, including in Beijing. And there have been lots of public health efforts depending heavily on predicting how the disease can be actually impacting. Now the disease new name for coronavirus is COVID-19, COVID-19. This is the definition by the World Health Organization, which is spreading, unfortunately, across the globe. During the early days of this new outbreak, when reliable data are still not available, researchers actually turn to mathematical models that can predict where people who could be infected are going and how likely they are going to bring the disease with them. These computational methods use known as statistical equations that calculate the probability of individuals transmitting the illness. My dear friends, modern computational power allows these models to quickly incorporate multiple inputs, such as given disease ability to pass from person to person and the movement patterns of potentially infected people traveling by air and land. This process sometimes involves making assumptions about unknown factors, right? There are individuals, exact travel pattern. You need to plug in different possible versions of each input, and researchers can update the models as new information becomes available and compare the results to observe patterns for the illness. For example, if a researcher and investigator want to study how closing a particular airport could affect a disease's global spread, their computers can swiftly recalculate the risk of importing cases through other airports. All the humans need to do is update the network of flight routes and international travel patterns. But when working with incomplete data, a very small error in one factor can have an outsized effect. Uncertainty about something such as COVID-19's basic reproduction number, known as R0, the average number of new cases caused by an infected individual, can actually totally change the model result. If you are wrong about this number, your estimate will be off by orders of magnitude, says a physicist at the Institute of Theoretical Biology and Humboldt University of Berlin and Robert Koch Institute in Germany, Dr. Dirk Brockmann. The current estimated R0 for the novel coronavirus varies from 2 to 3, placing it somewhere near the previous outbreak of SARS of R0 of 2 to 4 in 2003, but much lower than measles of R0 of 12 to 18. Because each unknown factor introduces more uncertainty to the model, Brockmann and some other researchers are focusing on a more limited model that relies on just one main factor. Brockmann's group has concentrated on using international flight data without figuring in person-to-person transmission to predict which airports represent the highest risk gateways for the coronavirus to spread worldwide. The risk predicts the expected sequence of countries you would find cases in, Brockmann explains. The way it unfolded is very much in line with what the mobility model predicted. Flight data can come from official aviation databases, making them fairly reliable, but they do not involve people's movements on the ground. For that information, researchers use very different sources. Alessandro Vespignani, a physicist and director of the Laboratory for the Modeling of Biological and Socio-Technical Systems at Northeastern University. They lead a team that is simulating the novel coronavirus spread using official air travel data and predicted commuting patterns among census populations. Despite they are not taking into account the person-to-person transmission with an R0, such travel-focused models seem to have consistently and accurately predicted which countries face the highest risk of getting new cases of COVID-19. Vespignani says if different models point in the same direction, you are more confident there is some level of realism and consistency in the results. Another recent effort to estimate how the coronavirus is spreading, both inside China and globally, internationally, incorporating individual mobility data from both flights and ground travel patterns during the period of the Lunar New Year holiday, which fell on January 25 of this year. When outbreak was picking up steam and really increasing, there was a very interesting paper I found out in Lancet. That was published on January 31st. The Hong Kong-based researchers estimated this year's holiday travel patterns by using information from the 2019 Lunar New Year travels of millions of people who use the WeChat app. You are using probably some other apps or WeChat. So people who are using WeChat app and other services owned by the Chinese tech giant Tencent. And unlike the purely travel-focused models, this study also included person-to-person transmission estimates, along with travel patterns based on both official flight data and Tencent's individual mobility data. Its results was very interesting. They also suggest that COVID-19 had unfortunately already taken root in many major Chinese cities as of January 25th, and those cities' international airports helped spread the virus internationally. So these methods are very important, dear friends. In addition to combining known and uncertain factors about travel and transmission, the impact of public health interventions, I recommend all of you to adopt face masks. Unfortunately, some school closures or common public areas, larger governmental measures such as China's decision to quarantine the entire cities, along with international travel bans and constraints. The Hong Kong researchers estimated that China's quarantine of Wuhan, which started on January 23rd, was unfortunately very limited in the difference it made because the disease had probably already spread to other cities in the nation. Still, the authors did recommend that draconian measures that limit population mobility should be seriously and immediately considered in affected areas. Public health experts seem uncertain about the effectiveness of such travel restrictions within and between cities. Other studies of past outbreaks suggest that harsh constraints on movement have only limited effects in delaying the international spread of the diseases. Some researchers work on modeling the results of changes in public behavior and government actions before they happen. Lauren Gardner, a civil engineer and co-director of the Center of Systems Science and Engineering at Johns Hopkins University, has been refining a model designed to help U.S. government officials decide which airports should screen arriving passengers with temperature checks and questions, and which ones are unlikely to encounter new cases of the novel coronavirus. This information could allow local governments to distribute resources where they are likely to be most needed. There has been lots of interest from various regional public health offices in using these results to prioritize surveillance efforts, Gardner says. These teams are just a few of those working to predict the future spread of COVID-19. Physician, which actually is doing a wonderful work, Elizabeth Halloran. Kudos to Elizabeth. She is the director of the Center for Inference and Dynamics of Infectious Disease, headquartered at the Fred Hutchinson Cancer Research Center in Seattle. In Seattle, they are doing really good work, and she is saying that during the 1980s, she could count on her fingers the number of research groups doing such modeling work. Now there are hundreds. We were on a phone call organized by the U.S. Centers for Disease Control and Prevention the other day, and she mentions that there were 80 call-ins from research groups. And she says there are a lot of excellent groups, and they operate together as big network. Nobody has all of the necessary data to achieve 100% certainty about the outbreak's future. It's like, ladies and gentlemen, like a puzzle, and all these researchers are trying to actually grab and then combine and work together to build and find the right models to predict how it is spreading. And despite all these variety of models, many ultimately agree on key points. For instance, between February 4th and 5th, the number of confirmed cases rose from fewer than 25,000 to more than 28,000 within the span of a day. But at the time, West Vigiani points out, various models agreed the real count was much higher. I believe every modeling approach was pointing to something that was over 100,000 cases in the best case scenario, he says. At the time, this article that mentioned the number of confirmed cases was greater than 45,000. And let's watch this Wuhan video together and see what is the situation on the ground.
Hello, I'm Ursula Phoenix Ware with the Centers for Disease Control and Prevention. I'm here today with Dr. Nancy Messonnier, Director of the National Center for Immunization and Respiratory Diseases at CDC. CDC has been responding to an ongoing outbreak centered in China caused by a new coronavirus. Recently, the disease caused by the virus has been named Coronavirus Disease 2019. Many people have questions about this new virus and the rapidly evolving situation, both in the United States and around the world. Dr. Messonnier has offered to answer a few questions, sharing some of what is known about this new virus. Welcome, Dr. Messonnier.
Thank you.
What is novel coronavirus?
Coronaviruses are a family of viruses that cause everything from the common cold to more severe disease. They generally circulate in animals, but they can jump to humans, and they've caused diseases like MERS and SARS in the past.
Okay. And who is at risk for coronavirus?
Right now, the people at highest risk for coronavirus are those who live in Hubei province, China. I know Americans may be concerned, but all the cases in the United States are in people who have traveled to China or their close contacts.
Okay. And how does coronavirus spread?
The data right now says that coronavirus spreads through respiratory droplets. That means coughing or sneezing.
Okay. And we understand there's symptoms. What are the symptoms of coronavirus?
The symptoms of coronavirus are fever, cough, and shortness of breath. Those symptoms are the same that you'd have with the viral respiratory infection, for example, like the flu.
Okay. So what can people do to protect themselves against coronavirus?
The most important thing for people in the United States to understand is that their immediate risk for novel coronavirus is low. We would suggest that they stay informed, but also that they take everyday usual precautions. They should cover their cough, wash their hands, and stay home when they're sick.
Thank you, Dr. Messonnier. For the latest on novel coronavirus, please visit CDC's webpage at cdc.gov/COVID-19.
Our third technology news is about a very interesting smear of DNA. Just a smear of DNA, ladies and gentlemen, can hold 10,000 gigabytes of data. So, as we all know, we use very different things to use storage. And there's a storage crisis. And investing $48 million to turn DNA into living hard drives is what I'm going to talk about. It is very interesting that close to $50 million is being used to put the DNA into the living hard drives. And this news has been provided by Emily Mullen. Thanks to Emily for providing this news. Around the world, you can see warehouses the size of several football fields store millions of hard drives worth of data. Every time we just send an email or search Google or upload photos to Facebook or stream a movie on Netflix or write something on LinkedIn or Instagram, basically all the time those hard drives are put to work. Big tech is building more of these sprawling data centers to keep up with the massive growth in data needs. But we are generating so much additional data that our current storage systems won't be able to keep up for long. Already, large-scale US data centers cost hundreds of millions of dollars to maintain the account for nearly 2% of the country's electricity consumption. And those numbers are only expected to grow. There's a problem coming where we are going to have more data than we can store, says Nicholas Gies, a senior research scientist at the Georgia Tech Research Institute who works on cybersecurity. According to Nicholas Gies at Georgia Tech Research Institute, to solve this problem, we will need to figure out how to store more data in less space. The United States government, which also has a huge data storage problem, has just invested $48 million into one possible solution: storing data into your DNA. There is a problem coming where we are going to have more data than we can store. For the past few years, researchers have been tinkering with encoding songs, images, and other files in DNA, but it is still very expensive and time-consuming. Now, a new program launched by the Intelligence Advanced Research Projects Activity, IARPA, a research agency within the Office of the Director of National Intelligence, aims to change that. Its goal is to shrink a warehouse-sized data center into an affordable table laptop device that can store 1 exabyte of data, which is equal to 1 million terabyte-sized hard drives. The scale and complexity of the world's big data problems are increasing rapidly, and there is an era when the solutions will require storage and random access from an exabyte or more data, says David Markowitz from the IRP program manager of 10. So David Markowitz mentions that they have faced with exponential data growth. Large data consumers may soon face a choice between investing exponentially more resources in storage or discarding an exponentially increasing fraction of data. Back in January, IARPA awarded Guy's team about $25 million to start working toward this goal, together with some other collaborators. His group will work from San Francisco-based DNA synthesis company Twist Bioscience, San Diego startup Roswell Biotechnologies, and a team at the University of Washington that's collaborating with Microsoft to develop a fully automated DNA data storage system. This is truly exciting, ladies and gentlemen. And meanwhile, researchers from the Broad Institute of Michigan Institute of Technology, MIT, and Harvard and French company DNA Script have been awarded a separate contract worth up to $23 million to work on ways to encode data into DNA and to retrieve that information. Like big tech companies, the government also needs archival data, storage capabilities that are more affordable than conventional systems. The federal government collects and stores data on everything from taxes and crime to public health and climate. DNA offers an extremely compact means of storing immense amounts of data. A data storage facility as big as Walmart Supercenter could be shrunk down to the size of a sugar cube. About 10,000 gigabytes or 10 terabytes can be stored in the pink smear of DNA at the end of just a little test tube. Ladies and gentlemen, being able to put 10,000 gigabytes or just 10 terabytes into a just pink smear of a DNA at the end of a little test tube is thrilling and amazing. So getting data into DNA is similar to traditional coding, with a few more steps. On a computer, data is coded into sequences of zeros and ones, known as binary code. DNA, meanwhile, can store data using a quaternary code consisting of A, C, G, and T: adenine, cytosine, guanine, and thymine. The 4 chemical bases or building the blocks that make the DNA. Just like a bit of information on a computer has a value of 0 or 1, each chemical base can be viewed as a bit. Bits of information can be encoded in DNA by machines that print out synthetic DNA bases or to reflect the desired sequence. Advances in manufacturing DNA are making this process faster, but it can still be very slow, depending on the amount of data that's being encoded. Guys mentions that it can take up to a few minutes to add each base, but his team is hoping to speed up that process so the data can be put in much faster. The real limiting step is how long it takes to chemically synthesize DNA, which is much smaller than how long it takes your body to replicate DNA, he says. To retrieve or read the data, scientists must use a sequencing machine. DNA sequencing is the process of spelling out of the order of the A's, C's, G's, and T's. But extracting just one file or a few files is challenging because DNA is so small, making a particular piece of data hard to pinpoint. The University of Washington group involved in IRP project is developing a chemical that could essentially find and bind to the particular piece of data you want to extract and read. In 2016, the same researchers reported that they were able to encode 4 digital images in DNA and then successfully retrieve them without any data loss. The University of Washington and Microsoft Group has since encoded all sorts of things in DNA, from an OK Go music video to the top 100 books of Project Gutenberg. One of the advantages of DNA is that it can be preserved for hundreds of years, Unlike the hard drives, flash drives, and magnetic tapes that are used today, which degrade in years or decades, DNA can be stored in a liquid form or dehydrated into a powder, which makes it last longer. Once scientists create enough synthetic DNA, which information encoded in it, they will next need to figure out how to store these tiny amounts of liquid and powder. One storage approach is dehydrating DNA so that it can be organized into tiny specks in vials depending on what kind of data it encodes, says Adam Meyer, a senior research scientist at Georgia Tech who is leading the project with guys. Thanks to Adam for his hard work. And what he mentions is, depending on which data you want to read, you would find a very different spot of powder and feed that into a DNA reading device. Another possibility would be to route liquid DNA onto the surface of small storage chips. When they started to produce more and more of this stuff, they will have to come up with a solution, basically. So I wish the best of luck to Meyer. Also, Guys says that DNA also has potential security benefits over traditional storage systems, since it requires having a DNA sequencing machine, which costs hundreds of thousands of dollars to read encoded data in the near future. The average person probably won't buy DNA for data storage like they do an external hard drive, but they will likely end up using it without realizing it if companies like Apple and Facebook move from the cloud into the DNA storage. Very interesting, isn't it? Some of the main users of these giant exabyte scale data farms are places like Facebook or Apple, and a lot of what they are storing is people's photos, Guys says. This covers also some other areas like YouTuber. As you know, the YouTuber uses neural networks to upscale 1896 short film to 4K 60 FPS. It turns out Enhance could soon become more than a television trope. This is according to Adrian Potoraka on February 5th. So I want to thank you for this show. Thank you very much. And this is covering our current technology program, 3 technology news. Thank you very much. Have a nice day. Goodbye.